When you hear the term AI, what comes to mind? Probably sci-fi robots, right? Or some secret all-powerful algorithm. But what if the real story isn't about the machine at all, but about the people building it? Today, we're going to go inside Europe's AI labs to see how the research is really done. No hype, no slick marketing, just the actual science.
Look, we all use AI every single day. We talk about it constantly. But how many of us actually know how it's made? Like, what does it really take to have a genuine breakthrough? I'll give you a hint. It's not just about a bunch of code and data. The real process is way more careful and, well, as you're about to see, it's surprisingly human.
So yeah, forget everything you think you know from those splashy headlines and big tech product launches. We're going to pull back the curtain and show you a totally different way of building AI. It's a method that's a lot quieter, a lot more careful, and it's all about one thing, the public good. And where does it all begin? Well, it starts with the lab itself. The very philosophy of these places, their foundation, it shapes every single thing they create. It's a fundamentally different approach, right from the ground up. See, the core mission here is just different. A lot of these top European labs, they're connected to universities, to public institutions. So their goal isn't just to be the fastest or to make the most profit. The number one priority is to build technology that actually serves society and does it safely and reliably. And that mission, it's not just some nice-sounding statement on a website. It translates into 3 core values that are totally non-negotiable: transparency, ethics, and a real sense of public responsibility. Every single project, every single line of code has to measure up to these principles. Okay, so how does a project even get started? You might be picturing some lone genius coder, headphones on in a dark room, but the reality, it couldn't be more different. It's way more collaborative and, honestly, a lot more thoughtful. It really does take a village. AI research here isn't just for computer scientists. It's this incredible conversation between all these different experts. You've got doctors in the room defining the actual medical problems. You have ethicists asking the tough questions about the impact. And then you have the computer scientists and mathematicians designing the tools. This whole setup makes sure the technology is grounded in real-world needs, right from day one. And this is so important. The technology serves the question, not the other way around. These teams don't just invent some cool new algorithm and then go looking for a problem to solve with it. No, they start with a really meaningful challenge, something like, how can we detect cancer earlier? Or can we make our climate predictions more accurate? And only after they have that question do they start building the AI to try and answer it. All right, so once the project is a go, the real work begins. And this is where that careful, sometimes kind of slow, scientific process really kicks in. And let me tell you, it is not always glamorous. Let's just take data access, for example. You know that whole move fast and break things mentality? Well, this is the complete opposite. Getting permission to use sensitive data, like patient records, can take months. It's this long, careful review process to make sure everything is anonymized, secure, and ethically approved. Yeah, it might slow things down, but it's absolutely crucial if you want to build systems that people can actually trust. And here's something you almost never hear in those big, flashy tech announcements. Most AI experiments fail. Like, a lot. It's totally normal for a model not to work on the first try, or the second, or even the 10th. Failure isn't just common here, it's actually an expected and even necessary part of the whole process. Now, that's a huge shift in how we usually think about this stuff, right? But in good research, failure isn't a bug, it's a feature. Every single time an experiment fails, it tells you something important. It might reveal a flaw in your model, a hidden bias in the data, or just a wrong assumption you made at the start. It's this constant cycle of testing, failing, and trying again that leads to real, robust breakthrough. But let's say a model finally starts working. That doesn't mean it's just set loose on its own, not even close. There is always a human safety net. It's a critical piece of oversight that's built right into the design from the very beginning. This idea is absolutely fundamental, especially when the stakes are high, like in medicine. The AI is seen as a tool. It's there to help an expert, not to replace them. The final call, the ultimate responsibility, that always stays with a human. The goal is to augment our intelligence, not to automate our accountability. And that human oversight goes even deeper. Ethics aren't just a checkbox to tick off at the end or some PR move. It's a core function of the lab. The researchers themselves have to ask these really tough questions head on before they move forward. And if the potential for harm seems too great, the whole project can get shut down. Period. So, okay, when you add all this up, the methodical process, the built-in ethical guardrails, that focus on the public good, you start to see this really interesting tension between this approach and, well, how the rest of the world is doing it. And this really gets to the heart of the big debate in AI today. On one side, you have this European blueprint. It's careful, it's regulated, it's all about building trust. And on the other side, you've got this global race that's all about speed, with way fewer restrictions. It leaves us with a huge question. Can this slower, more thoughtful approach actually compete? Or is it maybe building something far more valuable for the long run? So what's the takeaway here? Inside these labs, an algorithm is never just a strung of code. It's the final result of intense debate, of countless hours of testing, and a really deep sense of human responsibility. It's a story about science, not just about being the fastest. And maybe that's the most important thing to remember. In a world that is completely obsessed with speed, with getting the next big thing out tomorrow, this whole approach points to a different path. It leaves us with one final and I think really crucial thought. When we're building the technology that's going to define our future, is the most important thing to be first, or is it to get it right?